Hi, welcome back. So in this video, we're going to continue our conversation about special angles, reference triangles, and the unit circle, and fill in the rest of the unit circle using some symmetry. So I have here the values that we've already found in the last videos for our special angles in Quadrant 1, and we're going to use this information for the other quadrants. So remember here that points have the form cosine of theta, sine of theta, where cosine is the x value and sine is the y value. So if we look now at Quadrant 2, so I know that across from 0 is 180 degrees, that's our pi, that's halfway around the circle. Then to match the 45 degrees in Quadrant 1, I have 135 degrees. So you can imagine taking 45 plus 90 and getting 135. Then for 120, that's 30 past 90. And 150 is 30 away from 180. So I'm not sure how helpful this is. The idea is we're just taking these angles in Quadrant 1 and mirroring them over to Quadrant 2, and so we are going the appropriate amount in degrees to get there. So if we look on the Quadrant 1, we go by 30, then we add 15, then we add 15, then we add 30. So I'm adding 30, 15, 15, 30 to get the rest of the degrees. As I said, I'm not sure how helpful that is. If you want to really get used to the patterns, I'd recommend printing off a plain unit circle and just practice filling in some of the values. It helps just get used to all the patterns that are going on. There are so many patterns to see here, it's actually a pretty good exercise. So I'm going to start with 180 degrees. Now, this point is over to the left by 1 and up 0. So that is a negative 1 on the x and 0 on the y. So that's because the circle has radius 1, so as I go to the left, I'm going over by a negative 1. We can follow this same logic for the other points. So if we look at 30 degrees, the 30 degrees went over by square root of 3 over 2 and up by 1/2. So the same thing is going to happen for 150 degrees, except now we're going to the left by square root of 3 over 2. So that's a negative x value. But we're still going up for a positive 1/2 on the y. So our point is negative square root of 3 over 2, 1/2. The 1/2 stays the same, but the x value becomes negative. Remember, these correspond to cosine and sine, so this means that the cosine value of 150 degrees is negative square root of 3 over 2 in comparison to the positive square root of 3 over 2 for 30 degrees. Okay, let's continue. For 45 degrees, I'm seeing that the x value is also what's negative. We're going to the left, but we're still going up the same amount. So we have a negative square root of 2 over 2 and a positive square root of 2 over 2 for my x and my y. Then lastly, for 60 and 120, my x value is negative 1/2. I'm going to the left by 1/2, which corresponds to a negative x value, and then up by square root of 3 over 2, which is a positive y value. Okay, so we have Quadrant 2 done. As we start to look at the other quadrants, I think it's going to be helpful for us to have the radians labeled in. So let me go ahead and put those in, and let me talk briefly about how you might fill these in, these radian amounts, without converting all of the degrees or looking at a unit circle. So I know that 180 degrees is pi. I remember that because a full revolution is 2 pi. Then looking at the 45 degree equivalent, the 135 degrees, this is going to be 3 pi over 4. My reasoning is that 4 pi over 4 would be all the way to pi. 4 over 4 is 1, and this is just 1 less than that, so it's 3 pi over 4. You can imagine doing pi over 4 3 times to get to 3 pi over 4. This is really good practice for your fractions. Then we could do 2 pi over 3 as 120 degrees. We're basically doing 1 pi over 3 and then another pi over 3. Or you can think that this is pi over 3 away from 3 pi over 3, which would be pi. I know it's a lot. Then our last angle is 5 pi over 6 for 150 degrees. You can imagine doing pi over 6 5 times, or you can think that we are 1 pi over 6 away from 6 pi over 6, which would be 1 pi. Anyway, I'm not sure how useful that is. I think it's good just to have the radians written down or to be able to reason through where it is on the unit circle. Okay, let's fill in the other quadrants. So 270 degrees is going to be across from 90 degrees. I've just added 90 to 180 degrees. And I know that a full revolution is 360 degrees. I'm going to do my pattern of adding 30, 15, 15, 30, 30, 15, 15, 30. So I'm getting 210 degrees, 225 degrees, 240 degrees, 270 degrees, 300 degrees, 315 degrees, 330 degrees, and 360 degrees. Now look, I know this is a lot of information, just bear with me. In the future, we'll just reference a unit circle that has all this information, so we don't have to think about it every time. It's a lot to keep track of. So for the radians, I'm just going to go ahead and fill these in. You could take some time to reason through it. So I have 7 pi over 6, 5 pi over 4, 4 pi over 3, 3 pi over 2, 5 pi over 3, 7 pi over 4, 11 pi over 6, and 2 pi. Okay, so let's fill in the other points for the angles related to 45 degrees. The ones that are like multiples of 45 degrees, or symmetrical to them. All of these have an x value of either positive square root of 2 over 2 or negative square root of 2 over 2. So the ones on the left side of the graph where there's a negative x value, they have a negative x, so a negative root 2 over 2. The ones on the right have a positive root 2 over 2 because they have a positive x value. So I'll fill those in. And similarly for the y values, or the heights, the ones above the x-axis have a positive root 2 over 2, and the ones below the x-axis have a negative root 2 over 2, since they have a negative y value. Okay, so we have those points. We need to just do this for the other angles. Let's do this now for the 30-degree related angles. So this would be 30 degrees, 150 degrees, 210 degrees, and 330 degrees. You can notice that all of these radians are divided by 6, so that's one way you can tell they're all related. So here, the same thing applies. The x values are negative on the left-hand side of the graph. The x values are positive on the right-hand side of the graph. Then the y values are negative on the bottom part of the graph, which is what both of our unknowns are. So I'm getting negative negative for 210 and positive negative for 330. Then lastly, we do our 60-degree angles. So we have 60 degrees, 120 degrees, 240 degrees, and 300 degrees. So here, our x values are negative on the left. So for 240, we have a negative 1/2, and they're positive on the right. For 300 degrees, we have a positive 1/2. Then we have a negative root 3 over 2 for the y because we're below the x-axis, and that's for both of those angles. So, okay, wow, that was a lot, but we made it. This is our complete filled unit circle. So a lot of teachers will have you memorize this, and there's so many patterns and so many tricks and ways that you can memorize it, but my opinion is that you're going to always basically have a phone on you where you could just quickly look up the unit circle and get this information. So while it might be good to be able to have it memorized, I kind of believe that you could do it and we don't need to go through the trouble. Also, in the next video, we're going to talk about how to find these values intuitively rather than just having something memorized, and I think that process of working through the thoughts and the intuition about how this works is much more important and really more mathematical than just memorizing something. But we will talk a little bit about how to read this unit circle and get the information we need. So, okay, just some comments. As I mentioned, the unit circle is a lot of information. So I think it's easier to just remember one quadrant and then use symmetry to get the other ones. So once you kind of have the first quadrant, you can just reflect it around to get the other angles. It's not too bad. We did this just now, and really it just felt like a lot more talking than I even needed because we just needed to kind of copy the numbers in the right spots with the proper negatives. Then I also want to comment that the xy axes can really help keep things straight for you. So remember that x values are positive on the right-hand side and negative on the left-hand side. Y values are positive above and they're negative below. So just to summarize that really briefly, if we have our 4 quadrants, we would say that the first quadrant has a positive x and a positive y, so a positive cosine and a positive sine. The second quadrant has a negative cosine and a positive sine because it's negative x, positive y. Then quadrant 3 has negative x, negative y. So that's a negative cosine, negative sine. And quadrant 4 has a positive x, we're going to the right, and a negative y, we're going down, and that's a positive cosine and a negative sine. So you can just imagine if I was plotting a point in any one of these coordinates, what would my values be? Would they be positive or negative for the x and the y? Okay, so that's how we fill in our unit circle using symmetry and using our information about the first quadrant special angle values. Thanks so much for watching, and I will talk to you in the next one.